If you like these videos, please check out my full course at www.lsat.totaltestprep.net with tons of clearly explained actual LSAT questions written by someone who's mastered test and helped others master it, and an evaluation period where you only pay if you want to continue.
Okay, now let's take a look at what these statements mean in a little bit more detail. So here I have the some cats are black, and I've actually symbolized it with a little bit of a modification. I put an S outside of the conditional statement with parentheses to indicate that it is a sum statement. So as I've written here, some and some aren't, and most aren't statements have different properties than regular conditional statements. So some A or B says the same thing as if there are things in group A, then some of those things are in group B. So you've got groups A and B, and it tells you that just some of the things in group A are in group B. So some essentially means at least one, but potentially all. A standard way of visually symbolizing it is we've got these what are called Venn diagrams. You don't have to remember that name, it's a technical term, but it's basically circle A and circle B and an overlap between them. So as you see, circle A, or rather, circle A represents the one group of things, one of the two, or the first of the two groups of things in a sum statement. So in this case, A could stand for cats. So you've got all of the cats in the world in that circle. And then B stands for the second element in that syllogistic statement, in that sum statement, and black. So it stands for all of the black things. So you've got a circle for all of the cats and a circle for all of the black things in the world. And where they overlap, that overlap in the middle, that shaded region in the middle there between the A and the B, that is all of the cats that are black, because that is the part of the circle that is the cats and the part of the circle that is the black things. So that tells you that there are certain cats that are black. And this is a standard way of just visually symbolizing what's going on. You don't have to remember, you don't have to memorize this in terms of for how we're going to be doing the questions. This is just to visually represent to you what these sum statements and what these syllogistic statements in general mean in terms of that overlap between groups. So this is just a way of kind of visually representing that. However, notice as I wrote there on the left, I wrote that some means at least one, but potentially all. So essentially, some means there's got to be some overlap between the two circles, but it doesn't. You can have them overlap completely. So, and this is actually different from the everyday meaning of some, which generally doesn't include all. When I say some cats are black in everyday speech, I'm implying that there's some cats out there that aren't. But on the LSAT, when you see some, it can also mean all. You don't know exactly what it is, but it's at least one. So there's got to be at least one common element between the two groups. But it could be that the first group is completely inside the second. So for example, this is another way of doing it. So this also is a visual representation of some A or B, or if A is cats and B is black things, then some cats are black. This just implies that all of them are actually black. Now, but if you know that one of those things is in group A, then you don't know if it's also in group B. So that's the thing with the sum statement. You know that at least one of the elements in the first group is going to be in the second group, but you don't know which one, and you don't necessarily know that it's any specific one. And that is represented by that top diagram with the two circles that are overlapping with the area in the middle. So if you just pick a cat at random, you might pick a cat from the overlapping area in between the two letters, or you might just pick a cat just where it's just straight up green, blue, turquoise blue, whatever it is, whatever color that is, that greenish color. So you could just pull it out from that circle that has no connection with the purple, with the B circle. So you don't know if a particular element in the first group is going to be in the second. You don't know if a specific cat is black, but you know that at least one will be. And if something is not in group B, you can't say that it's not in group A. So this is also the same thing. Just because something is not a part of group B, just because something's not black, does not necessarily mean that it's not a cat, because it could very well be something outside of that B circle, but it's in the A circle, for example, in the top one. Okay. Now, some A or B doesn't necessarily imply that some A are B. Now, this is counterintuitive because it's opposite to how we use sum in real life, but it's different in LSAT logic. So just because some A are B, you have some A or B, that doesn't necessarily mean that some A aren't B, and you can see that by that second symbolization on the bottom. Because once again, going back to what sum means at least one, potentially all. So if you have a situation where all A are B, that is expressed by a statement that says some A or B, which you can do that. It's a little confusing, but you can do that with that quantifier, with that syllogistic quantifier. You don't necessarily then know that there are A's that are not B's. And like I said, that's represented by that second diagram on the bottom, where every single A is a B. So just because some A are B, you can't assume some A are not B. However, you can actually reverse the two of them. So you can say that some A are B means that some B are A, and that is because you're always going to have an overlap between them. That's just what some means. Some means there's always going to be an overlap. It may be a total overlap there where they're completely overlapping, or as we have here in the bottom, one of them is inside the other, or the other one. We could have also had B inside of A. That is all captured by some A or B, as long as there's some overlap. The most intuitive and the most common one is the one we have here on the top, where it's just two separate circles with a little bit of overlap. But you definitely want to keep in mind that as long as there's an overlap, it's a sum statement. But what that means is that means that you're going to have some B that are A. So whenever you say that some cats are black, you're saying that some black things are cats. Okay. Now, let's take a look at this statement. So some cats are not quick. So that is symbolized the same way. We got the S outside, we've got cat, and then arrow not quick. So some A are not B says the same thing as if there are things in group A, then some of those things are not in group B. So in this case, some are not means at least one isn't, potentially none. And this is where it's a little bit different from what we had or rather, it's kind of consistent with your expectation, given that some is a little different, and so some are none is also some are not is also a little bit different, because it implies specifically potentially none. So if you say some cats are not quick, you could be saying that there are no cats which are quick, just by virtue of what some are not means. And so here's the way of visually representing that. So the first one is your standard one, because you've got an A circle and a B circle overlapping, and as long as you have part of the A circle that is not part of the B circle, that also means some are not, because that means that there are things inside that A circle which are not inside the B circle. So we have that in that top one, those two top circles represented as well. But so do the middle ones, because even though in the middle, this is an example where it's no A or B, can also be expressed as some A are not B, or rather this manifestation is also captured by that statement. It's a little, like I said, it's a little counterintuitive, because in everyday language some implies there's at least some that are, but if you say some are not, on the LSAT and in logic you don't necessarily imply that, so you can visually represent that with just two separate circles. There's no cats that are quick. A is the circle of all cats, B is the circle of all quick things, so we're just living in a universe where every cat is kind of slow. So that is also captured by some A or not B. And so is the last one. So is the last one, which is that maybe you have the B circle is a smaller group of things that is inside the first circle, the A circle. So some cats are not quick. So that would be like saying that there are some that every single thing in the world that is not quick is a cat. Now, as long as there's some cats that are I apologize. What that's saying is that B is all of the quick things in the world. So there's nothing. The only thing that's quick is a cat. But then there's also some cats that are not quick. That's the area of the A circle outside of the B circle. So that would be kind of like saying, some alcoholic drinks are not made from grapes. So A is the circle of all alcoholic drinks. B is the circle of all alcoholic drinks made from grapes. And so that would actually be captured by that last diagram, because every single alcoholic drink made out of grapes is also an alcoholic drink. But there's ones that are made from, vodka's made from grain, whiskey's made from grain, barley, whatever it is. So you're going to have ones that are not that. So that this last diagram captures that kind of relationship, where you've got some elements out of a general group don't belong in like a subgroup. You can think of it that way. But that's also captured by some cats are not quick. Here, the basic thing you're looking for in this relationship is that there are elements in the first group which are not elements of the second group. And so these are sort of three ways that you want to be aware what that might mean in a more sort of sophisticated understanding of their relationship. The most common way of visualizing is the top one, is the first one, where you have just two separate groups. They have an overlap, but they also don't have an overlap. Although keep in mind that because it's potentially none, it can also be the second one. So, like I said, this is different from the some aren't, which generally doesn't include none. And a synonym for some aren't is not all. So when you see not all, that doesn't mean none. That just means some are not. Now, if you know that one of these things is in group A, you don't know if it's not in group B. Okay? So if you see that something is, and this is just once again the thing with some is, so just look at the top two circles just for the in terms of the most straightforward explanation of this. If you know you're dealing with something in group A and you pull it out of group A, you don't know if you pulled it out of the part of the circle that's not overlapping or the part of the circle that is overlapping. So just because you know you're dealing with something that's in that group, you have no idea if it's outside of the B circle. So you can't say that just because something is a cat, it's not quick. And unlike the previous one, some A aren't B does not imply some A are B. Or rather, sorry, this is like the previous one. You can't just simply negate it. So you can't say that just because you know that some A are not B, that you can then say, oh yeah, some A are B. The reason the reason for that is because if you look at the middle situation where there's just two separate circles, so you know that in this case some A are not B because none of them are. But that doesn't mean that there is an overlap. You can have a some are not relationship without any overlap. And actually, unlike some, this is what I was getting at, you can't just reverse it. So when you know that some A are not B, you can't say that some B aren't A, and that's actually what we have in the bottom circle down there. So just because you know that there's elements in A that are not going to be in B, you might have a situation where every single B is a smaller subgroup within A, so you can't say the same thing starting from there. And that's once again because some can mean all. Now, in terms of additional statements, so we've got the most statements. So we've got here most cats are pets, and we'll symbolize that with an M and then parentheses cat arrow pet. And so most A are B says the same thing as if there are things in group A, then most of those things are in group B. And most means more than half, but it also means potentially all. So you see how some of these, like some aren't, most, and we'll see most aren't, are tricky in the sense that they include or they introduce meanings that you won't find in everyday speech. So when you say most, you generally don't mean all, but unfortunately on the LSAT you do. You just have to keep that in mind. And so a way of visually representing that is, once again, we've got these two overlapping circles, and what we see here is just that the area of the overlap has to be bigger than the area that is not overlapping in the A circle. Because if you're saying that most A are B, what you're saying is that when you divide A, most of the things in A are going to also be in group B. So we have that in just kind of intuitively in the top circles, but it's also saying the same thing in the bottom ones, because like I said, most can include all. And so once again, this is different from the everyday meaning of most, which generally doesn't include all, but here you can do that. So you can have a relationship between between two elements joined by most, where everything in that first group of elements is associated with that second group of elements. Okay, but if you know that one of those things is in group A, you don't know if it's also in group B. Same thing. So this is the difference between when you say all and none, which is the regular if then. Here, just because you know that there's a cat out there does not necessarily mean it's a pet. So just because you know that it's part of the group of A does not necessarily mean that it's in B. And if something is not in group B, then you can't say that it's not in group A. So the same thing. If something is not in group B, it may be in group A or it may not be in group A. Now with respect to the other one, most cats are not fat. So most are not. Same thing, you just negate the necessary condition in that syllogistic statement. And most A are not B says the same thing as if there are things in group A, then most of those things are not in group B. And so this is the way we can draw that. So once again, it's parallel to some are not in that it can also mean none. So that's the other thing. So most are not can also mean none. We've drawn the other thing to keep in mind is that the overlap has to be smaller than the non-overlapping area for A, because once again, that's what it means. That means if you take all of the things in A, then less than half of them, and potentially none, are going to be in B. And that's what we have in these three situations. But if you know that one of those things in group A, you don't know if it's not in group A. If it is in group A, then you know if it's not in group B. Same thing, because it's dealing with most, it's dealing with all of the elements and then their majority. So you take the elements, you figure out the majority, and then you know that the majority is not going to be in the other one, but you don't know if that specific element falls in that group that is or in that group that isn't in B. And if something is in group B, you also can't say that it's not in group A. So the other way around, you can't just simply say if you have most cats are not fat, then you can't say that most fat things are not cat, and then on the basis of that say, oh, it's a fat thing, so it's not a cat. Once again, you don't know. It could be that it's not at all. It could be that it very much is, depending on where you take it from.